So this is GCSE Papers Shadow Set 1, Higher Tier, Paper 2, Thursday 6th of June 2019 paper. So going to take a look at question 9. This question that starts regarding the circumference of a circle and the ratio of the area of those two circles. So we're told that the circumference of circle B is 80% of the circumference of circle A. You need to find the ratio of the area of circle A to the area of circle B. So I'm going to start off by writing out circumference of A to the circumference of B. Now it tells us that the circumference of B is 80% of the circumference of the circle A. So I'm going to say the circumference of circle A is 100, and therefore 80% of 100 is 80. Now I've just picked that number of 100 because it's going to make things easy to deal with. Okay, I don't actually need to know what the circumference is. This question is not about knowing that the circumference of a circle is to do with pi times the diameter or 2 times pi times the radius. It is a ratio question, and it is also a question to do with linear scale factor and area scale factor. So this is quite a tricky question to work out and to recognise what you have to do. So like I said, if the circumference of circle A is 100, then the circumference of circle B would have to be 80. Next thing I'm going to do is I'm going to simplify this ratio just to make things easier. So that would go down to 10 to 8, and it would simplify again to 5 to 4, because now still this number is 80% of this number. Now hopefully you will know that an area scale factor is linked to the linear scale factor. Okay, now the circumference is a length, it's a linear measurement on the circle, and area is a square measurement. Okay, now hopefully you will remember that the area scale factor is the linear scale factor squared, or the length scale factor squared. Okay, that's absolutely key, and that's what this question is all about. Okay, and so we're going to use this to answer this question. So we know that that was the ratio between the circumference, or the lengths. Now area A to area B, using this formula, using this fact that we know, if we know that the length scale factor, the linear scale factor ratio is 5 to 4, then the area is just going to be those numbers squared. So the area ratio will be 25 to 16. And it would have been exactly the same had I left it 100 to 80 or 10 to 8. It would have simplified to 25 to 16. And that is the answer to that first part of this question, 25 to 16. Okay, if we move on to part B uses the same sort of techniques. Okay, it uses the same techniques, except we're talking about a square. So it says square E has sides of length E, square F has sides of length F. So again, we're talking about lengths. We're talking about the LSF, the length scale factor or the linear scale factor. The area of square E is 69% greater than the area of square F. The area of square E is 69% greater than the area of square F. So that's now relating to the ASF, the area scale factor. So what we know, area E to area F, we know that the area of square E is 69% more greater than the area of square F. Well, again, if I pick a basic number to start with, if I know the area of square F is 100, then the area of square E would have to be 169, 69% more. That's an easy way to start this ratio question. This is 69% more than this. Done. Okay, you need to work out the ratio of E to F. Now remember, E and F are lengths. we've got this area, we need to go back and find the lengths. So we're using this formula again, right? And when we went in reverse, we're going to have to use the square root. So this is very similar to part A, except this time I'm just going to need to square root these two numbers, and the square root of 169. It's a calculator paper. I will just double check. The square root of 169 is indeed 13, and the square root of 100 is of course 10. And there is the ratio of the lengths E to F, 13 to 10.